Traditional cloud platforms are centralized by design. Ownership, governance, access control, and decision-making are concentrated within a single provider. If you run sensitive workloads, you must trust cloud owners and system administrators not to misuse your data. SuperSwarm is a confidential, decentralized, self-organizing computing cloud that replaces trust in cloud operators with cryptographic verification. Swarm offers the same workload execution capabilities you would expect from a traditional cloud platform, but with no single point of control or failure. And thanks to confidential computing technology, SuperSwarm does not expose data to anyone. SuperSwarm is not just an idea on paper. What you see is a live test run on real hardware. 32 nodes around the world form a decentralized SuperSwarm network. Every node is a confidential virtual machine running within a hardware-based trusted execution environment, a TEE. It is a special isolated area of a CPU and GPU. Inside it, the code, data, and runtime state remain cryptographically isolated from the host system. No external party can access workloads running within a TEE, not even the hardware owner or the super protocol team. As nodes come online, they discover each other and establish secure connections. Nodes form an encrypted overlay network. The cryptographic keys are stored strictly within the trusted execution environments, and all inter-node communications remain confidential. Once connected, nodes verify each other, synchronize, and elect a leader. This leader groups nodes into functional clusters, Kubernetes, storage, or internal service. The cluster formation rules take into account nodes' hardware specifications and geographic locations. As conditions change, Swarm may reorganize itself. In this live run, the network already elected a leader and formed 2 Kubernetes clusters, one in Australia and another in the USA. For each node in the swarm, we can view its current load and which services are running on it. If a node becomes unavailable, the protocol gives it a grace period to recover. If it doesn't, the leader reconfigures the topology, regrouping nodes and reassigning responsibilities to keep the system stable. If the leader goes offline, the system initiates a new election. SuperSwarm is designed to be unstoppable. Joining SuperSwarm is intentionally simple. Got a server with a TEE? Plug it into the network and start earning. SuperSwarm will handle everything automatically under the hood. Now that you've seen how the system organizes and recovers itself, let's actually use it. To work with the cloud and request services, users must log in. In this demo, we use MetaMask as a login method. Let's create a workspace in a Kubernetes cluster. We select the region, define the compute resources, and specify whether the cluster should include a GPU. SuperSwarm automatically selects the best-suited cluster and creates a workspace. Once our workspace is ready, we can download the kubeconfig file and deploy an application just as we would with any other managed Kubernetes service. For example, let's deploy a simple Hello World application. Technically, it's just an NGINX deployment with an ingress. We also specify the domain on which the application should become publicly accessible. Let's apply the configuration. Even though this Kubernetes cluster operates entirely in a confidential environment, we interact with it the same way as with any standard Kubernetes cluster. At the same time, the workload will run within a TEE, protected from all external access. SuperSwarm has already detected the deployment. Before the application becomes accessible, we need to confirm domain ownership by adding a DNS record. A minute later, the domain has been verified, so the application should now be publicly accessible. Let's open it. Indeed, the application is running. Note that we don't know which servers our application runs on, and the server owners don't know that it runs on their servers. SuperSwarm is a secure, verifiable computing cloud for workloads of any complexity, including AI agents, databases, and storage systems. We made it decentralized, confidential, and self-sovereign by design. All system components are verified algorithmically without human interaction. No need to trust individual node operators or centralized authorities. Instead, trust is placed in confidential computing, cryptographic verification, and open source code. Super Protocol, making self-sovereign computing unstoppable.